Okay, I'm gonna talk in one single block about all these materials about impression materials. I'm gonna give you a general classification first so we know what we're talking about, and then I'm gonna divide it and talk about each other separately, okay? So impression materials, they are divided into two categories. You're gonna be elastic and rigid, okay? The elastic, we're gonna subdivide into hydrocolloids and elastomers. Hydrocolloids, they can be reversible or irreversible. Reversible, an example is the agar, and irreversible is the alginate. Okay, about the elastomers, they are elastic materials. The first elastic material that came out, it was called polysulfide. Polysulfide, it is called a mercaptan. We're not going to talk about this material because it's so old that dentists don't use it anymore. Okay, the properties are not very good. So new materials came out, and then we have new good materials, better materials than that. And those are called silicones. We have two types of silicones. We have polysiloxanes. And polysiloxanes, if you were wondering, it is silicone rubber, and it is the material that you use for bathroom caulking, okay, to seal stuff in the restroom, okay. But polysiloxanes, they evolved for polyvinyl siloxanes. They added this vinyl part over here. And this is a very important material in the dental office because dentists use it all the time, okay? They are really accurate. So we use them to take impressions of crowns and bridges. This is a paste-to-paste material. One paste is the base and one paste is the activator. So when you put them together, you have your material for the impression. This is a polymerization. Polymerization reaction, and is the most accurate material we have to take impressions, okay? The only two disadvantages of this material, one is that it's very expensive if you compare to alginate, and it's also hydrophobic. What phobic means? Doesn't like, right? So this material repels any kind of moisture, and saliva can become a problem during impression. It produces bubbles, okay? While before to pour on this material, you need to use a surfactant. So you increase the wetting of the material. You increase the contact of the material, okay, with the impression. So, but they are really reliable, and we really like them to take crowns and bridges. So the rigid materials are used only for edentulous patients. That means patients doesn't have any kind of retention, doesn't have teeth, okay? Um, and I'm going just to cite those because they are not really important. We have impression plaster, we have wax, which wax we use to take bite impressions. And we have ZO. ZO is zinc oxide eugenol. Okay, is also a paste, two paste, where one is the base and the other one is the activator. Usually dentists use as a second impression, so you know it's not very important. We're going to start to talk the very important stuff here, which are the hydrocolloids. Okay, and we're going to focus on agar and also alginate. Okay, those are the most important for the dental hygienist. Okay, let me give you a general view of hydrocolloids. Hydrocolloids, let's break down the word over here. Hydro means water, and colloids mean particles. So these water and particles, I'm going to give you the concept. So hydrocolloids is a suspension of particles in water. Okay, there is a basic reaction. The basic reaction of hydrocolloid is a liquid that becomes gel. But there is a scientific word for liquid over here. We always going to refer to the liquid as sol becoming gel. Okay? When they are irreversible, they just go this way. But when they are reversible, they go from sol to gel and gel to sol. Okay? And this is reversible. For example, I gave you already. We're going to repeat so you can memorize. That's agar, and irreversible is alginate. Okay, those are the two basic reactions. And by the way, the name of this reaction is gelation. Okay, don't forget that. Gelation. Okay. Okay, so let's start to talk about agar. As we talked before, and I'm going to repeat it, is a reversible hydrocolloid. That means it goes from sol to gel and gel to sol, okay? And sol to gel and gel to sol, okay? And how this happens? So in the sol form, which is the liquid form, we have high temperatures. Okay, it's hot. Now on gel is a gel, and it's also gonna be low temperature. And this is reversible. Every time you increase temperature, it's gonna be liquid. But every time you lower the temperature, it's gonna be solid. Okay. So agar comes from seaweed. Just to let you know, I'm not gonna give you the other components there or not. Agar is an old system, so dentists don't use it anymore. We are just giving like a general concept over here. But there are some terminology that we need to know, and we talked about this before. Thermoplastic. This is how when the concept applies to the dental material. Remember, the concept of thermoplastic is when cooling or heating is going to change the phase of the material. And that's true, right? Because when you increase the temperature, it's liquid, but then when you lower the temperature, it's going to become gel. Okay. Another concept we need to differentiate it is hysteresis. So hysteresis is when a liquid becomes solid due to temperature change. I'm not gonna go in details, I'm going just to give you the definition. Many times they ask what it is and we need to know, okay? So what are the advantages? If it's an old system, what is the advantage of using agar? The only advantage I can list for you is because agar produces a fine reproduction of details. Okay, whatever is inside of the mouth, the structures that are inside of the mouth, soft and hard tissue, is really well represented in the impression. But I can list you several disadvantages. And the first disadvantage is that the equipment. The equipment is really expensive. We use equipment called hydrocolloid bath. So the hydrocolloid bath is controls the water temperature, and you know we have to use special trays. The trays have holes that we connect and circulates water. So it's really expensive. Okay. There is a change in temperature, as we talked before, you know, to become from liquid to become solid, okay? And this change of temperature occurs inside of the mouth of the patient. So it goes from more or less 110 Fahrenheit to 80 Fahrenheit. So this is really uncomfortable for the patient. Okay. You know, if we talk about the impression itself, the impression is really fragile. That means if you take the impression and put your finger on, you already spoiled your impression. Okay, they are really fragile. The other major disadvantage is that you need to pour gypsum as soon as you take the impression. There is no waiting time. As soon as you take it, you need to stop everything and pour. And that's a huge disadvantage. And this is all we need to talk about agar. So I'm going to talk about hydrocolloid, irreversible, alginate, which is the most important for us, okay? Alginate is an irreversible hydrocolloid. And that means that it goes from salt to gel only. There is no back and forth. Okay, it is once you take it and that's it. Okay, once it's hardened, that's it. So alginate is composed of two things. We're gonna use a liquid, which is gonna be water, and we're gonna use the powder. And I'm gonna give you the composition of powder because sometimes it is on the test, right? So the powder is composed of 5 components. The first one is potassium alginate. Potassium alginate, the seaweed. It causes the gelation reaction. Okay, is the base for the gelation reaction. Then we have calcium sulfate. I like to write the formula, the chemical formula, because it's less confusing to memorize. So if you memorize the formula, you can associate in your test. So calcium sulfate is going to be the activator, and that means the calcium sulfate actually start the reaction, the gelation action, okay, reaction. Then we have sodium phosphate. sodium phosphate is a retarder. Retarder means that it's going to give you time enough to mix, to place in the mouth and take the impression. Okay, it's going to guarantee that you have time enough. And we have inert silica, and inert silica is a filler. And we have quaternary ammonia, which is an antimicrobial. So that's what we have in alginate. So what are the advantages of using alginate? It's cheap. It's also easy to manipulate. Okay, you don't need a lot of material to take an impression. It also is a hydrophilic. That means if you have a little bit of saliva over there, it will not interfere too much in the impression. Remember, I told you on the silicones they are hydrophobic, and they do make bubbles on the impression. One more is that it's accurate enough to produce a study model. Okay, what are the disadvantages? The disadvantages are basically related to dimensional changes. And I'm going to list 3 dimensional changes that are really important over here with alginate. The first one is the evaporation. So when you when you take your impression and you leave your tray out in the environment, water is going to evaporate. And what is going to happen? The alginate is going to harden. Okay, and it's really, really difficult to remove from the tray, so don't do that. Once you took the impression, you need to guarantee that the impression has 100% humidity. And how we do that? We wet some tissue, we wrap around and put inside of a Ziploc bag. Okay. Then we have syneresis. Syneresis is when the impression loses water also, but doesn't lose too much water that hardens. Okay, it's going to lose water, is going to shrink. Okay, and you know, if shrinks, your model is going to be smaller than the original with the person's mouth compared to the person's mouth, right? So the third one is imbibition. Imbibition is when the impression absorbs water. And this is going to also cause a distortion and is going to expand the impression. Okay. What else? Well, I'm going to make like a general considerations over here, because basically we talk everything about it. Alginate. The first consideration, as I told you, once you take the impression, you need 100% humidity. How do you do that? You wrap your impression in a tissue with water, okay, in a wet tissue, and put immediately inside of a Ziploc bag. Okay, this is going to guarantee 100% humidity. You can store this impression for 1 hour in 100% humidity. Okay, if you're taking longer than 1 hour to storage, like if you're taking like 3 hours, you need to put this inside of a closed container to guarantee that you have 100% humidity. Now, the general measurements. One scope that's just general, okay? It's not, you can use more if you want, but it's just general. 1 scoop of alginate is gonna be used for a quadrant. When you need to take just a half of mouth, then you use 1 scoop. 2 scoops of alginate is gonna give you for the maxilla, the amount for the maxilla. Oh, sorry, for the mandible. 3 scoops is gonna give you the amount for the maxilla, right? Because the maxilla is bigger, so you need 3 scoops over there. And the proportion of water is, here is 1 to 1, and here is 2 for 2, and here is 3 for 3. Okay, really basic and really symmetrical, right? So the last thing we're gonna talk about is tray selection and how we handle trays. So we're gonna pick the smallest tray possible. Okay, it's gonna be a loose fit. That means it needs to jiggle inside of the mouth, and we need 4 millimeters of thickness all around of the impression. Okay, you're not gonna press the tray until you reach the cusps and the incisal of the teeth. Don't do that. We need 4 millimeters in the bottom also. Okay, so we're gonna select the smallest tray, right? But how about if you don't reach anatomy enough? So you're gonna modify your tray. How are you gonna modify your tray? Using wax. Okay, so you use wax actually in 3 situations. When you have a high vestibule and you need to get out your frenums, so you add like wax. Okay, so it makes taller. You also are going to use wax when there is a high palate. So to reach that high palate over there, you need to make more base over there. And when you need to cover the most distal molar and the heteromolar pad and the mandible, or the maxillary tuberosity. So that means when your tray is too small, you're gonna add over here. You're gonna add all this wax over here, so you can reach the last molar and the hetero maxillary tuberosity. When the palate is too deep, because for example a patient is a mouth breather, so you're gonna add wax over here. Okay, and that's all we need to talk about material impressions.